Hey everyone. In this video, I'm going to talk about data and measurement. And specifically, before we start talking about fitting our regression models, um, usually it's a good idea to think about exactly where the data is coming from, where the numbers are coming from, and what the underlying variables ultimately represent and to what extent they're related to, our underlying concepts of interest, right? And so what we're going to talk about in this video and the following kind of coding example is to show how we can use graphical tools and visualizations to explore and understand our underlying data as well as measurement of concepts that we're interested in. Okay, first, to kind of introduce different broader issues in measurement, there are a couple of kind of different concerns that we usually have when we talk about measurement issues. Okay, the first kind of broad category of issues related to measurements are validity and reliability. Okay, what we mean by validity and reliability is that a measure is valid to the degree that it represents what you're trying to measure, right? Giving the right answer on average across a wide range of plausible scenarios, right? So that's kind of like measuring what you intend to measure. Okay. Reliability, on the other hand, addresses the question of whether a measure is kind of stable and precise, right? So a reliable measure is one that is precise and stable, and there's less variability, and to the extent that there is variability, it basically is only due to random error and not due to some systematic deviation. Okay, so there's a quick kind of illustration of what it means for a measurement to be valid or reliable. So if a measure is valid, both reliable and valid, it's kind of straight to kind of measuring exactly what we're trying to measure and very precise. If it's reliable but not valid, it's still precise, but it's not hitting the mark. Unreliable but valid, it's correct on average, so to speak, but it's not very precise. And of course, the worst case, unreliable and unvalid. We're not getting it right on average, and it's very unprecise. Okay, so those are different kind of properties or potential issues with measurements that we're going to talk about: validity and reliability. Okay. Another issue that is very much related to measurement that is going to come up a lot as well is the issue of sample selection and selection bias. Okay, and this is kind of the canonical example that is always brought up whenever someone talks about sample selection, so I figured I'll use it as well. This is an example of a British bomber during World War II. Specifically, it is a visualization of British bombers that came back after flying over Germany and landed back in Britain, and they basically kind of collected data on where the bombers were hit by other fighters or anti-aircraft cannons or whatever. So they collected data on where their bombers are ultimately being hit, right? And so, looking at these data, one thing you could potentially conclude based on these data is, okay, I see there lots of hits in certain areas. So what should I do? We should put stronger armor in those areas that are more likely to be hit, right? So on the wings, on the sides of the wings, and right here, we need to reinforce the armor of those bombers in order to protect them and protect the pilots, right? And obviously that conclusion is false. Why is it false? It is false because there's a sample selection process that is not being taken into account, which is there are bombers that didn't return, right? Where we couldn't actually collect the data on where they were hit. And of course, those are all the bombers that had that were actually hit in areas like around the cockpit and so on. So ultimately, conditional on survival, conditional on the bomber coming back to Britain, it's wrong to conclude that we need to reinforce the areas that were hit, but rather, if anything, the opposite conclusion would be true. We have to reinforce areas that were not hit, because those are the areas that were ultimately probably would determine that they didn't return. Okay, so this is an actual historical example where a Hungarian mathematician ultimately kind of made this connection to selection bias and sample selection. Um, so that's kind of the idea of sample selection that is also related to measurement, of course. The key point, though, is that we can examine a lot of these problems using graphics, using visualizations, both to understand our statistical models, but also understand these underlying issues of data and measurement. And we're going to look at one specific example of how we can do that in the next video, right? So overall, graphs are extremely useful in examining these measurement issues and kind of getting a better idea of where your data is ultimately coming from. And so in the larger context of our kind of research workflow and our statistical workflow, we ultimately go back and forth between data exploration, modeling, and inference and model building. And ultimately, in each of these steps, we kind of need visualizations and graphics to kind of help us understand both kind of the data, the measurement, the models, the implications of those models, and graphical tools are crucial in each of those steps. Okay, so this is just summarizing kind of three uses of graphics in statistical analysis, kind of in connection with this question of data and measurement issues, right? So the first step, oftentimes when you encounter a new data set, is just looking at raw data, looking at descriptives. This is kind of what we often think about as exploratory analysis, looking at distributions of variables, conditional distributions, holding some other variables constant to kind of get a broader understanding of the underlying data, as well as the variables and what they measure, right? The key here is we're using graphics and we're using plots to help with that, to kind of explore our data. But they're mostly the only recipient, the only person who looks at those plots is ourselves, ultimately, as we work with it, right? So the goals for these plots is not that for these graphics is not that they're pretty, that that they have a nice design or layout. The goal is to just get an idea, get a better understanding of the underlying data, and potentially see and observe things that you didn't necessarily expect, right? The second kind of use of graphics in statistical analysis is to create graphs of fitted models and inferences, right? So sometimes this can mean overlaying data plots in order to so having like a scatter plot and then plotting a model like on top of that in order to kind of understand the model fit and things like that. But other types of kind of plotting simulations of replicated data from fitted models to kind of understand what the implications are of our fitted models and so on. And then lastly, graphs presenting your final results, right? So this is kind of the third crucial aspect of graphics for understanding statistical models, because ultimately we want to communicate our results to others, right? Ultimately, we want to write a paper or write a report or have a presentation, and then graphics are a key communication tool, right? We'll talk a lot more about how we can kind of in a concise way kind of focus on the key comparisons and communicate them to others, right? And again, one key thing to keep in mind is that all graphical displays can be considered as comparisons. They're always kind of invoking some comparison, and we kind of have to think about what is the comparison that I want to convey, what is the information that I want to convey, and how can I make this comparison as clear as possible. So we always have to kind of keep in mind which is the most important comparison and how can I make that as clear as possible, right? And so as we kind of go, like when we keep that in mind, as we create our graphics in each step of this analysis, whether it's exploratory, whether it's like looking at model fit, or whether it's looking at communicating the results of our analysis, we kind of have to keep those steps in mind. And in each of those steps, we also each of those steps also helps us ultimately then understand or better understand, you know, underlying issues with data and measurement. Okay, and so this was a kind of a quick, broad overview of kind of questions related to data and measurement. And in the next video, I'm going to talk about a specific example, particularly a comparison of the Human Development Index, or average human development index measure comparing US states, and we'll draw some conclusions about these measurement issues and how we can examine those using graphics and graphical tools.